U.S. Physics Olympiad 2024 USAPHO. This examination had two parts, Part A and Part B. Each part had 3 questions and lasts for 90 minutes. I offer private tutoring for Physics Olympiad preparation. I currently have openings. There is a discount for group classes. Message me if interested. My email is fred1996@hotmail.com. Problem A1. Ping pong. A thin wire of negligible resistance and total length d is wound to form a thin cylindrical solenoid, of length, L, much less than d. A conducting sphere of radius, r, much less than, L, is attached to each end of the solenoid. Initially there is no current in the wire, and the spheres have charges q and negative q. Give all your answers in terms of r, L, d, and the speed of light c equal 1 over square root from mu 0 epsilon 0. Question A. Assume this system can be modeled as an L-C circuit. What is the angular frequency of its oscillations? This system loses energy because it emits electromagnetic radiation. Consider an electric dipole, consisting of charges plus minus q0 cosine omega t separated by distance d, whose dipole moment oscillates with amplitude p0 equals q0d. If d is much smaller than the wavelength lambda of the radiation produced, then it can be shown that the power radiated is roughly, that is up to an order 1 dimensionless factor, p, proportional to expression 1. For the rest of the problem, your answers only need to be similarly rough estimates. Question B. For this setup, the above formula applies if d much greater than d0. Find a rough estimate for d0. Question C. Assuming d much greater than d0, estimate the number of oscillations that occurs until half the energy is lost. Question A. Assume this system can be modeled as an L-C circuit. What is the angular frequency of its oscillations? Solution for question A. Since the potential on the spheres is approximately equal plus minus q over 4 pi epsilon 0 r, the capacitance of this system is C equal q over delta V, where delta V equal q over 2 pi epsilon 0 r, so capacitance approximately equal 2 pi epsilon 0 r. Its inductance can be found using regular expression for solenoid, L equal mu 0 n square s over L, where n is number of turns and s is cross-sectional area of the solenoid pi a square. If the radius of the solenoid is a, then d equals 2 pi a n, then we have L equal mu 0 d square over 4 pi L, the angular frequency of L, C, oscillations omega equals 1 over square root from L, C, which is C over d multiplied by square root from 2 L over R. That was solution for question A. Solution for question B. The radiation produced has angular frequency omega, so wavelength lambda equal C over omega, which is of order d square root from R over L. The Larmor formula works when lambda much greater than L, which corresponds to L much less than d square root from R over L. Finally we have d much greater than d0, which is order of square root from L cube over R. That was solution for question B. Question C. Assuming d much greater than d0, estimate the number of oscillations that occurs until half the energy is lost. Solution for question C. The total stored energy is of order Q square over epsilon 0 R. Thus, the typical number, n, of cycles for the energy to decay is approximately the inverse of the fraction of the energy that is radiated away in each cycle, so, n, is order of square root from, r, d power 6 over, l power 7. This is roughly the quality factor of the, L-C, circuit. Note that we implicitly assumed above that many oscillations occur before half the energy is lost. This assumption made sense because we know that, n, is much greater than square root from, r, d 0 power 6 over, l power 7. Which has order of, l over r, and is much greater than 1. That was solution for question C. And here we finish discussion on problem A1.